Okay, just for the record, here's where the difference quotient comes from. If you have a function and you're trying to find the slope at x, we have a point x comma f of x. In order to figure out the slope, we take another point, add a small horizontal distance h to get to a new point. If you start at x and go over h, you end up at x plus h. Okay, so we so we take the limit. Let's see. What are my 2 points? I'm going to just write them up here. I have x comma f of x and x plus h comma f of x plus h. So the rise over the run is going to be difference in the y's over the difference in the x's. And the only thing that cancels is the x's. As we've seen from a few examples, if you have h inside, it gets all gumbled up into the function itself. You have the FOIL, you have the square root, whatever. Okay. And we have our difference quotient. Lovely. Okay, so the slope of the line, what is f of x plus h? I'm not going to rewrite that until I write the limit. So what have we got for a limit? Because we have got, apparently I decided limited space. So we got limit as h goes to 0 of that's all f of x plus h. So my suggestion is put f of x plus h in parentheses and then f of x in parentheses. That way it's easy to tell that you've got both of them. Yeah, what does that come out to? Let's see. The 2x squareds cancel. The 3x's cancel. Let's see. And because we're being a little lazy, we're just going to factor the h's out in our head. And it's the limit as h goes to 0. How do you check this on the calculator? I'm going to put this in a box. I'm going to find two actual points that are close to each other, so. Let's trace it 1.1 and 1.01. So then I'd have, as a difference quotient, it's trying to approach 0, but as a secant line, as a line connecting two actual points, I have 2 points. Let's see, 5.72 and 5.072. Calculator says that's 7.2. That's close enough. There's also second calc dy dx. So
second trace.
Now you know a little cheating method to find out the number. Incidentally, a little last note. We could have plugged in 1 at the very beginning or any time in the middle. So you may see it without any x's at all sometimes if they're just trying to find the slope at a single point. I like to do x at the end because you will find out very soon that 4x plus 3, the derivative of 2x squared plus 3x, is fairly easy to find fast. Okay, fine. All right, so a first application. The velocity is change in position over change in time. So if I want instantaneous velocity, I need the derivative, the difference quotient. If I want the average velocity, that's the slope between 2 points. So that's the same thing, except with different letters. Instead of y and x, we have p and t, p for position. So, negative 3t cubed. Okay, let's just go over here and cube out t plus h cubed. Do you remember that from the Pascal triangle? I knew I taught you these things for a reason. Okay. So all right, what do we got? Oh, yeah. So, looking very much forward to the next problem. I think it's the next problem set where we're going to introduce some quick tricks for this because this is ridiculous. Maybe it's the one after that. Be careful when subtracting. Again, I strongly suggest putting the original function in parentheses and the thing you're subtracting in parentheses. It helps cut down the arithmetic mistakes. The negative 3t cubes cancel. And the rest of it all has h's. So cancel out an h. There's my velocity formula, and then v of 3 is negative 81. There we go. Average velocity is the old-fashioned slope. Change in position, change in time. I need 2 times. So, for instance, if I say the first 2 minutes, the time, so. Okay, so we're looking at the time interval from 1 to 3. I need P of 3 minus P of 1 over 3 minus 1. What is P of 3? Let's see. Remember we, sorry. So then, what do we have now? We have negative 81 minus negative 3 over 3 minus 1. Negative 39. Okay, so one little note. We just calculated the speed at the end, and that was negative 81. So that's plausible. If I look at this picture, I'll just draw it here. I'm imagining something going down faster and faster. If I calculate the slope at the end, it is going to be steeper than the slope in between the 2 points.